So, good morning. First year Bcom Computer Applications, Semester 1, Fundamentals of Information Technology, Unit 2. Unit 2 లో మనకి Unit 2 లో మనకి second unit is number systems. There are two essay type questions. First one is number systems, second one is storage units or storage devices. So, we already begin with number systems. So, today we start another PPT. Why? Because it is an essay type question from first unit, from second unit, compulsory essay type question from second unit. So, we start with another PPT of number systems. So, number systems another PPT ఎందుకంటే కంపల్సరీ essay type question మనకి. So, what are number systems? Number systems means each number system is associated with a base or radix value, base or radix or index value. The number system, decimal number system is said to be of base or radix of 10. Why? Because it is having only 10 numbers 0 to 9. A number in base R contains R digits, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 up to R minus 1. Decimal base 10 number system have 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, what is that? Each number system is associated with a base or radix, base or radix. So, the decimal number system is said to be of base or radix or index of 10. Why? Because it is having 10 digits in it. It is having 10 digits in it, like 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that is total 10 digits. A number in base R contains R digits, that is 0, 1, 2, 3, 4, 5, 6, 7 up to R minus 1. Decimal number system, that is base 10, having digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Numbers are usually expressed in positional notation. Numbers are usually expressed in positional notation. So, what is positional notations? What are positional notations? Means, for example, n of R is equals to like that A0, A1, A2, A3 up to An minus 1, where n is the small n is the capital number of digits. Integer dot means similarly a minus 1, a minus 2 up to a minus n. So, the extreme left digit is called as MSD or most significant digit, and extreme right digit is called as the LSD or the most least significant digit. The point is called as the decimal point or a radix point. So, left side part of that point is called as integer part and right side part is called as the fractional part. So, generally numbers are expressed in the any numbers are generally expressed in this way by using some number position, So, ante మనం for example మన number 123 అనేది ఎలా వచ్చింది అంటే 1 into 10 square plus 2 into 10 power 1 plus like that అన్నమాట. So, numbers, the value of the numbers is given in the polynomial form. So, how numbers are formed means in this way by using this formula only. N of R, capital N of R So, numbers how to form numbers? The value of the number is given in the polynomial form. This is the formula. So, NR is equals to sigma 1 is I is from minus m to n minus 1 ai into r of j. That is the formula. That is the formula for forming regular numbers or daily numbers, decimal numbers and or any numbers in any format are used in this format. So, in addition to decimal, there are other 3 number systems are also there, important. They are called as binary, octal and hexadecimal. Binary, octal and hexadecimal. So using binary numbers, the binary number system having the base of 2. In binary number system we are using only 2 digits, that is 0 and 1. The digits in a binary number are called as bits. What is bit? Bit means binary digit. Binary digit means that is either 0 or 1. Either 0 or 1. So it is in a simple example 10110 like that. The extreme right digit is called as the LSB digit. What is LSB? Means least significant bit. LSB means least significant bit, and the extreme left digit is called as the most significant bit, MSB. Most significant bit, MSB. So how this binary form or binary number is converted into decimal point? So here we are using some decimal number also. Here we are having some decimal digit also. So starting from extreme left digit, that is what is the decimal part, what is the whole part, that is 101101. What is the decimal part? 101. So starting from the extreme left digit of decimal part that is 1. So 1 into so writing in this form we may get 45.625 of decimal number. So unsigned binary numbers. So every numbers have 2 parts or 2 types, signed and unsigned. Signed means it is having some sign also, including the sign also, that is either positive or negative. Unsigned means only positive numbers. So next step is converting binary to decimal. How to convert binary? How to convert a binary to decimal numbers? For example, convert 1101.01 in binary to equivalent decimal. So first write the binary digits by giving or by writing them with some space, giving by space, that is 111 space 1 space 0 space 1 dot 0 space 1. So there are 2 parts, decimal part and integer part and decimal part. Integer part means left side of the decimal number, decimal symbol. So every number have 2 parts, integer part and decimal part. What is integer part? Integer part is nothing but the number which is presides right side of the decimal symbol, and the number which resides in the right side of the decimal number is called as a decimal part. So by taking integer part, that is 1101, starting from the extreme, so the conversion should starts with extreme right digit. So the first right digit is 1. So 1. So the base or index of binary digit is 2. So starting 1 into 2 power 0 plus 0 into 2 power 1 and 1 into 2 square plus 1 into 2 cube. It is called as weights. 2 power 0, 2 power 1, 2 square, 2 cube, all these are called as weight of the base or weight of the number system or weight of the index of the number system. Similarly, another part is of decimal part. Decimal part is the number which is after the decimal point, that is 0 and 1. Here 0 into 2 power minus 1, we are taking negative values for decimal numbers or decimal part, and 0 into 2 power minus 1 plus 1 into 2 power minus 2. So this is the conversion process from binary to decimal. So after 2 power 0 means any number power 0 means it is 1. So the final result is 8 plus 4 plus 0 plus 1 plus 0 plus 0.25. So that is equivalent to 13.25. So the binary equivalent, the decimal equivalent of binary 1101.01 is equals to 13.25 of decimal number. 13.25 of decimal number. So every number have two components or two parts, integer part and decimal part. Integer part is the number which is placed on left side of a decimal point or a decimal symbol, and decimal part is the part or the system which is having right side of that number. So every number have two parts, decimal part and integer part or integral part and decimal part. Integer part having the number which resides or left side of the given number, and decimal part means the number on the right side of the after decimal point. So converting decimal to binary. So converting decimal to binary. So how to convert a decimal integer into binary? Keep dividing by 2 until the quotient is 0. Collect the remainders in reverse order. To convert a fraction, keep multiplying the fraction part by 2 until it becomes to 0. Collect the integer part in the forward order. Example, decimal 162.375. So convert decimal 162.375 into equivalent binary number. So how to convert a decimal number into equivalent binary number? To convert a decimal number or a decimal integer into binary, keep dividing it by 2 until the quotient is 0. Collect the remainder in reverse order. To convert a fraction, keep multiplying the fraction part by 2 until it becomes 0. Collect the integer parts in forward order. Example, convert the decimal 162.375 into equivalent binary number. So decimal part is 162 and fractional part is 375. So 375.375. So take the decimal part, that is whole part or integral part, that is 162 by 2. So in the division we know that there are when we divide when we do or perform a division operation, there are two outputs are there, one is quotient and one is remainder. So 162 by 2 means that is 81 is quotient and remainder is 0. Again take the quotient as number, that is 81 by 2 means 40 is the quotient and 1 is the remainder, and 40 by 2 means 20 is the quotient and 0 is the remainder. So continue this process till we get the quotient becomes 0, So write down the write down this with step by step manner, and write the binary number from bottom to top manner. For integral part, write the binary number from bottom to top, that is 10100010. And for fractional part, what is the fractional part? 0.375. Fractional part is 0.375. So 0.375 into 2, again that is 0.750, again 0.750 into 2, that is 1.500, again take the fractional part 0.500 into 2 means 1. So now so this is the procedure to convert a decimal number into equivalent binary number. Next is octal and hexadecimal numbers. So what are octal numbers? So as we already know that the number systems are 4 types of number systems are there: decimal, binary, octal and hexadecimal number systems. So Next step is octal and hexadecimal numbers. The octal number system is having base of 8. 8 digits are used, 8 digits are available or used in octal number system, that is 0, 1, 2, 3, 4, 5, 6, 7. So the octal number system have base 8, that means 8 digits are used, that is 0, 1, 2, 3, 4, 5, 6, 7, 8. So convert the octal 127.4, convert the octal 127.4 into equivalent decimal number. So how to convert an octal number to into equivalent to decimal number? The hexadecimal number system similarly, so take the example of 127.4 of octal number system. So the decimal fraction is, decimal part is 127 and fractional part is 0.4. So take the starting with extreme right digit of the decimal number, that is 127. In 127 extreme right digit is 7. So 7 into 8 power 0 plus second digit is 2, 2 into 8 power 1 plus 1 into 8 square, that is the decimal part, and this fractional part is 0.4, fractional part is 0.4 plus 4 into 8 power minus 1, that is 87.5. So the octal decimal equivalent of octal 127.4 is equals to 87.5 decimal. So third number system is the hexadecimal number system, that is having base of 16, that is having base of 16. Why? Because 16 digits are used, 16 digits are used in hexadecimal system, so that its base or index value is 16. So what are the numbers or digits used in hexadecimal number system? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 means capital A, 11 means capital B, 12 means capital C, 13 means capital D, 14 means capital E, 15 means capital F. So 0 to 9 they are 10, 0 to 9. After 9 it is 10, decimal 10. Decimal 10 means capital A, it is represented in hexadecimal form, it is capital A. Decimal 11 is means capital B, decimal 12 means capital C, 13 means capital D, 14 means capital E, and 15 means capital F. So for our purposes, base 8 and base 16 are most useful as a shorthand notation for a binary number. So this table is generally represented or converted all the decimals or decimal number systems from 0 to 15 to equivalent binary, octal and hexadecimal numbers. Equivalent binary, octal and hexadecimal means decimal 0 means binary 0 0 0 0, octal 0 and hexadecimal 0. Decimal 1 means 0 0 0 1 1 1, like that. So you can convert between base 10 and base 8, base 10 and base 8 and base 16 using techniques like the ones we just showed for converting between decimal and binary. So next is binary and octal conversions. Next is binary and octal conversion, converting from octal to binary and vice versa, that is from binary to octal. So replace each octal digit with its equivalent. Replace each octal digit with its equivalent bit or binary sequence. For example, so similarly we can converting from binary to octal. While taking binary to octal, there we may take 3 bits as a unit. While converting binary to octal, we may take 3 bits as a unit. While converting from hexadecimal to decimal, binary to hexadecimal, while converting from hexadecimal to binary to hexadecimal, we may take 4 digits as a unit. That is the 2 important points to be remembered. And so how to convert a decimal octal number to equivalent binary number? While taking octal to binary number, we may take 3 digits as a unit or as a sequence. So next is binary and hexa conversions, converting from hexa to binary, similarly from binary to hexa. So first one is converting from hexa to binary. Replace each hexa digit with its equivalent 4-bit binary sequence. So example is convert hexadecimal to 61.35, convert hexadecimal to 61.35 to equivalent binary number. So in this process, first write down the digits with by giving some spaces 261.35. So in hexadecimal, for hexadecimal to binary, first you have to take 4 bits as a unit. So convert 2 decimal 2 to equivalent binary number, that is 10. Add 2 zeros before it. So 0010, and 6 means 0110, 1 means 0001. Why? Because we are taking 4 bits as a unit. Dot 3 means 0011, and 5 means 0101. So this is the binary decimal equivalent, hexadecimal equivalent of binary. Again, converting from binary to hexa, make groups of 4 bits, starting from the binary point, add zeros to the ends of the number if needed, convert each bit group to its corresponding hexadecimal digits. So here is example, that is convert the binary number to equivalent hexadecimal number. So to convert any binary number to its equivalent hexadecimal number, take 4 bits, take 4 bits as a unit, and then convert it the number into corresponding hexadecimal part, a decimal and hexadecimal. So this is the solution for converting binary 10110 point like that into equivalent hexadecimal. First take 4 digits as a unit and convert it into decimal, and then convert it into hexadecimal. So it is equivalent to B4.2C. So this is the summary of this number system PPTs. This PPT about number systems. Computers are binary devices. Means what? Binary numbers means binary devices, or binary numbers means machine language. Binary numbers means machine language. So computers can understand only binary number system or machine language only, not decimal, octal, hexadecimal. So everything should be converted into binary number only. So computers are binary devices. We are forced to think in terms of base 2. So everything will be in base 2 or binary numbers only. We learned how to convert numbers between binary, decimal, octal and hexadecimal. So and we have already seen some of the recurring themes of architecture. We use 0 and 1 as abstractions of analog voltages. We should how to represent numbers using just. So why binary or 0 and 1 means, in electronic terms, or in power terms or electrical terms, 0 means 0 and non-zero, 0 and 1, 0 and non-zero, 0 and 1. 0 means high voltage, or 0 means true, or 0 means yes. Non-zero means anything which is not 0 means non-zero. That is called as no, or no power, or false. That is the notation of the binary number system. Okay, thank you.